Algebra 2. Today we're going to look at Section 6.2 in our textbook, and our learning target is how we multiply and divide radical expressions. I will also be showing you how to simplify radical expressions without a calculator, so you're not giving decimal answers. First, we're going to look at just the general rule for multiplication. To multiply radicals, you need to look for two things. The index numbers must be the same. And remember, the index numbers are the numbers, like the little numbers that are inside the radicand. So the n in this case would be the index. Once you check to make sure that these are equal or the same number, then you can go ahead and multiply. And to do so, you're going to multiply the radicands together. And remember, radicand is a word we used in the last section, meaning the number, variable, or the term underneath the radical. You're going to simplify the product as best you can. Also, if you do happen to have a number in front of each of these, for example, if this one was 3 and this one was a 2, you would also go ahead and multiply those together and put it in front of this answer. Make sure your index numbers are the same. Go ahead and multiply, if there are numbers outside, multiply them together first, and then multiply the radicands together and simplify the product. Just a review on how to simplify radicals without a calculator, without giving a decimal answer. Question number 1, we have the square root of 54, x to the 4th, y to the 7th, and z to the 3rd. And recall from the past that we have looked at perfect squares before. And so when you're looking at perfect squares, you're looking for numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. You only use perfect squares, of course, when you are dealing with square roots. So for question number 1, first thing you need to do is make sure that 54 is not in this list. And you can see that it is not. So that means that there is no whole number times itself that will equal 54. Your job is not to use a calculator. I don't want you just typing in square root of 54 and giving me the decimal, which is like 7.35. I don't want that answer. I want it in radical form. And so what we need to do is try to find the biggest perfect square in this list that will evenly divide into 54. So you're going to start with 54 divided by 4. Since that's a decimal, we're not going to choose that one. 54 divided by 9 does work. 54 divided by 16 is a decimal. 54 divided by 25 is a decimal. 54 divided by 36 is a decimal. Does not work. 49 is too close. 64 is too big. So 9 is the perfect squared number that will nicely divide into 54. And so your job is to write 54 as factors 9 times 6. Please remember, I want to see everyone doing this, underline the part that is the perfect square, so that way you and I both know that that's what you intend to simplify in the next step. Then you're going to look at the variables independently. X to the 4th, we can definitely simplify, but for right now, I know that 4 divided by 2 is going to work, but I don't want to answer it yet. So we're going to show this in the next step. The square root of y to the 7th. 7 divided by 2 is not a whole number. So what you're going to do in this case is you're going to break y to the 7th up into factors, and what you're trying to do is get as close as you can to 7. Like y to the 6th times y to the 1st is the same as y to the 7th. The reason we want to do that is because y to the 6th in the next step can be simplified. We can definitely do the square root of 9. we can definitely find the square root of x to the 4th as well as y to the 6th. Then your job is to look at the z's. When you divide 3 by 2, it is not a whole number, so your job is to write z to the 3rd a different way. You're going to break it up into factors, z to the 2nd times z to the 1st. And again, you want to always make sure you underline each part or piece that can be simplified. And so, square root of 9, x to the 4th, y to the 6th, z to the 2nd, all of these that I've underlined and highlighted are going to need to be written outside the radical. One step at a time, the square root of 9 is 3. You can only give me the positive version because you notice you do not see the plus minus out in front. Square root of x to the 4th, recall from the last section, you're going to divide the power by the index. 4 divided by 2 is 2. The square root of y to the 6th is y to the 6th divided by 2, which is 3. The square root of z to the 2nd is z to the 2 divided by 2, which is z to the 1st. And then once I've gotten all those pieces simplified, notice that they are not underneath the radical. Then you're going to go ahead and bring your radical down beside of it. And anything that is left underneath the radical that cannot be simplified is going to have to stay. 6, y, and the z. I know it looks messy right now, but this is called the simplified radical answer. Okay? Alright, we're going to move to, let's go to number 3 next, only because I do notice that it is a square root and I can still use these perfect squares to the side. So we're dealing with the square root of 60. The first thing I want to do is look for 60 in this list, and I do not have it. So 60 is not a perfect square. In other words, there's no two factors multiplied together that gives you 60 back. You're then going to start with 4. We're going to divide 60 by 4. And that does give you a nice whole number back. 4 times 15 is 60, so we want to check that one. Divide 60 by 9. That does not work. 60 divided by 16. 60 divided by 25. By 36. By 49. And then 64, of course, is too big. So the only one I found in this list, besides 1, of course, is 4. And so we're going to write this as 4 times 15. And again, please underline the piece that you know can be simplified. Next, you're going to look at the p. P is to the 6th power. We can divide 6 by 2 and get a nice whole number back. So what we're going to do is we're going to just keep it, leave it alone for now, drop it straight down. We'll take care of it in the next step. The square root of q to the 15th, when you divide 15 by 2, it is actually 7.5, and so that's not a whole number. So we want to simplify, like we want to write q to the 15th a different way. Again, you want to get as close as you can to 15. So I'm going to do q to the 14th and q to the 1st. I'm going to underline the pieces that I know I can take the square root of. I can do the square root of 4. I can simplify the square root of p to the 6th as well as q to the 14th. The square root of 4 is 2. The square root of p to the 6th is p to the 6 divided by 2. The square root of q to the 14th is q to the 14 divided by 2, which is 7. And I've gotten all my pieces there, so next I'm going to drop down my radical. And anything that is not underlined cannot be simplified any further with a radical form. So I'm going to bring down 15 in the q, and this is my final answer. 2p to the third q to the seventh times the square root of 15q. Alright, next, I want you to notice question 2 has a index of 3. And so we're looking for cube roots right now. Cube roots are based on perfect cubes. So 1, 8, 3 to the third, 27, 4 to the third, 64, 5 to the third, 125, 6 to the third, 216, 7 to the third is 343, and so on. 8 to the third would be 512. 9 to the third is 729. 10 to the third is 1000, and then I'm going to stop there. Of course, this list does not stop, it keeps going forever, but that should get us a pretty good list going. And so let's focus on this set right now. Perfect cubes we want to always look at when we're dealing with cube roots. You, of course, are going to come up do the same game plan. Excuse me, you're going to look for 54 in this list. I do not see 54 in the list, meaning there's no whole number times itself 3 times that gives you 54 back. You're going to drop the cube root symbol down. You're going to start with 8. You're going to divide 54 by 8. And it does not work. You're going to divide 54 by 27. And yes, that one works nicely. 54 divided by 64. 64 is already too big. So I know 27 is the accurate perfect cube that I need to use. And I'm going to write 54 as 27 times 2. Again, underline the part that works. Then you're going to ask yourself, can you take the cube root of 8 to the 9th? When you divide 9 by 3, is it a nice whole number? And the answer to that is yes. So for right now, we're not going to change 8 to the 9th. We're just going to drop it down. You're going to look at b to the 13th. Can you take the cube root of b to the 13th? 13 divided by 3 is not a whole number, and so we want to write b to the 13th into factors so that at least one of the factors is divisible by 3. So again, you want to try to get as close as you can, and when you're writing it, think about, is 12 divisible by 3? So that way, kind of thinking ahead, it should work. We're going to go back and we're going to underline all the pieces that we know we can take the cube root of. Again, I'll highlight these two. And to complete this, we're going to do the cube root of 27, and that's going to be 3. The cube root of a to the 9th is a to the 9 divided by 3, which is 3. The cube root of b to the 12th is b to the 12 divided by 3, which is 4. And then we're going to drop the rest of it down. Now remember, please remember to bring down that index, because if you forget that little 3, then your entire answer is wrong. So this is extremely important that you keep an eye on the index number. That is a common mistake for people to forget. You're going to drop your 2 down. You're going to drop your b down. And I've got all the parts, so that should be it. This is your best answer. Okay, question 4. Notice that in number 4, the index number is actually 4. And so perfect squares are not going to help me, and perfect cubes aren't either. What we've got to do is come up with a list of powers of 4. 1 times 1 times 1 times 1 is 1. 2 to the 4th, 2 times 2 times 2 times 2 is 16. You'll keep that moving the same pattern. 3 to the 4th is 81. 4 to the 4th is 256. 5 to the 4th is 625. 6 to the 4th is 1,296, and you can continue if you need to. Okay, so you're thinking about it in terms of powers. Okay, powers of 4 for the 4th root. Because remember, raising a number to the 4th power and then turning around and taking the 4th root of it, we learned in the last section, are inverses of each other, and so that's why this needs to be our game plan. Notice that 80 is not in this list. 81 is, but not 80. So we're going to write 80 a different way. We're going to choose 16. 80 divided by 16 is actually 5. So 16 times 5 is a good way to write it down. And underline the 16. We'll come back and simplify that in a minute. Your next move would be to look at x to the 9th. Can you take the 4th root of x to the 9th? 9 divided by 4 is not a whole number. So we want to write it as x to the 8th times x to the 1st. Then our eyes are focused on y to the 20th. 20 divided by 4 actually does work. So remember, for now, we're not ready to simplify. We're just getting things ready. You're just going to recopy it. Last, z to the 3rd. I can't divide 3 by 4 and it be a whole number. And because this power is actually smaller than the index, I really can't write it a different way either and achieve that same goal. So when this happens, just leave that alone. Go back and pick up my red pen. This one can be simplified. I can definitely do the 4th root of x to the 8th, and I can definitely do the 4th root of y to the 20th. All the other pieces I did not underline will stay underneath the radical. You're going to drop your index number down. Oh, I'm sorry. Jumped ahead of myself. We're actually going to simplify here. The 4th root is 16. 2 times 2 times 2 times 2 is 16, so that answer is 2. The 4th root of x to the 8th is x to the 8 divided by 4, which is 2. The 4th root of y to the 20th is y to the 20 divided by 4, which is 5. And then you're going to bring down your 4th root. Bring down your 5, your x, and your z to the 3rd. Okay, making sure you got all the parts. This is a simplified radical answer. So for the first 4 examples, again, all we've done is like review and learn how to simplify in radical form. We're not allowed to give decimal answers. Okay, and then remember the first thing we wrote down is the simple rule for multiplication. Once we do the multiplication part, then we'll have to simplify. Alright, so let's try these. Multiply the following if possible. Number 1, we've got the cube root of 6 times the square root of 2. The first thing you always check for in a multiplication problem is if the index numbers are the same. In this case, they are not. So you are not allowed to multiply these together. There is no product, so this one's not possible. No product, not possible, no answer. You can write any of those you wish. Question 2. We're looking at index numbers first. This one I see a square root. I also see a square root here, so I'm good on that part. Remember my comment from the first slide. If there is a number here, in this case it's just 1, and a number in front of this one, you are supposed to multiply these together. 1 times 1 is 1 though, so you don't have to write that down. Then you are supposed to multiply the radicands together. Negative 4 times 2 is negative 8. Next, you're supposed to simplify this radical if possible. I see a square root of a negative 8. This is definitely imaginary because no number times itself is negative. So I'm going to write this like we did in the complex unit as negative 1 times 8. I'm then going to take it one step further and not leave 8 because we're talking about square roots and we're looking at perfect squares. 4 definitely goes into 8, and so we want to write 8 as 4 times 2. So from here on out, you are always to simplify radicals when you see one that can be. These two pieces need to be underlined because we know answers for them. The square root of 4 is 2. Notice how it is out from underneath the radical. Square root of negative 1 is imaginary. That's the I part. And the 2 has to stay underneath. And so for question 2 on this slide, that's the best answer, 2i radical 2. All right, look at question 4, or question 3. Look at the index numbers first. I see a square root, and I also see a square root here, so I can continue. I'm going to multiply my numbers together. This is a 1, and this is a 2. 1 times 2 is 2. Now I'm going to multiply my radicands together. So I'm going to put this and this together with multiplication. I'm going to multiply 10 times 40 to get 400. I'm then going to multiply x to the second times x to the first. And again, we add powers when we're multiplying, so that becomes x to the third. I am now finished with the multiplication step, but I have to see if it simplifies. So, the next thing I need to do is check out 400. Is 400 a perfect square? Now, remember our list that we made and have made in the past, I always stopped at 100, but I told you guys that it does continue. So anytime you have a number higher than 100, my suggestion is you just type it in your calculator and see if it works before you go to any other trouble. Square root of 400 in a calculator will give you 20. Alright, so I'm not going to answer that right this second. I'm going to leave it alone, underline it, and do that in the next step. And the reason I'm doing that is because x to the third needs to be written a different way. I can't do the square root of x to the third, but I can break up x to the third as x squared times x to the first. And then these two pieces can be simplified. When there's a number already in front of the radical, that's being multiplied by the square root. So whatever this answer is, square root of 400, when it comes outside the radical, you are to multiply it by 2. So I always like to use parentheses here and just say, drop my 2 down. Square root of 400 is 20 on a calculator. So 20 times 20 is 400. The square root of x to the second is just x to the first. And then I drop my radical down. And the only thing that's left underneath this radical that's not been underlined is x to the first, so it has to stay where it is. And then, of course, don't leave me hanging there. You always want to simplify numbers. So 2 times 20 is 40. So this is 40x times the square root of x. And that is the simplified radical answer. Okay, question 4. We got a multiplication again. We look at the index numbers. They are the same. I don't see numbers in front, so that's 1. I'm going to go ahead and multiply the radicands together. Again, you can multiply anything together in algebra. So 12 times 6, that's just 72. M to the third times M to the second is M to the fifth. We're going to add powers. N to the fifth times N to the first is N to the sixth. Since we are talking about a square root, then we have to go to the perfect squared list. Look for the biggest number we know that goes into 72. 72 is divisible by 4. It is divisible by 9. It does not work with 16 or 25. 72 divided by 36 does work. 49 does not. 64 is getting too close. So 36 is the best choice because it's the largest perfect square. 72 is 36 times 2. Just like all the other problems we've done today, you're looking for m to the fifth, I can't take the square root of m to the fifth, but I can write it a different way. I can write m to the fifth as m to the fourth times m to the first. Again, get as close as you can to 5. And then n to the sixth. Now, n to the sixth, I can definitely take the square root of, so there's no need in me breaking it down into smaller factors, so I would just recopy it. And so the parts that we can actually simplify, we need to do this in the next step. We need to give a good answer for this piece as well as this piece. Square root of 36, one at a time. Square root of 36 is 6. Square root of m to the fourth is m to the 4 divided by 2, which is 2. The square root of n to the sixth is n to the 6 divided by 2, which is 3. Once you get all the pieces you've underlined, then you copy down your radical, and anything that's underneath that cannot be simplified is going to have to stay where it is. You've heard me say that multiple times. I just keep repeating it because it's very important. And that's your final answer. So multiplication is really not too bad. Just make sure that you keep in mind that the index numbers have to be the same. Look for that first. If you come to a problem where they're different, just stop. Don't go on. And then secondly, multiply the radicands together and then simplify your answer when you can. And as always, if there's numbers in front, go ahead and do that too. Okay. All right, let's try 2 more for multiplication. And then we'll stop for today. Number 5, I have the square root and a square root here. To multiply it, I'm going to multiply the 72 times 10. Call that 720. X to the second times x to the first is x to the third. Y to the fourth times y to the third is y to the seventh. And then I am looking for perfect squares. So 720 is definitely not in that list. You start at the top. 720 divided by 4 actually does work. 720 divided by 9 also works. Divided by 16, that also works. 25 does not. 36 does. 49 is the next one. It does not. 720 divided by 64. No. 720 divided by 81. Divided by 100. Divided by 121. $144. Oh, 144 actually does work. So 720, the best way to break this down and to get to the answer fastest is to always choose the largest perfect square you can find. So 144 times 5 is 720. We cannot do the square root of x to the third, so we're going to write this as x squared times x to the first. Y to the seventh becomes y to the sixth times y to the first. And we underline what we can simplify. Square root of 144, the answer to that is just 12. And again, it's not the square root of 12. Be careful. If it simplifies, it comes out from underneath. The square root of x to the second is x to the first. The square root of y to the sixth is y to the third. Then I write down my radical, put my 5, and my x, and it looks like my y. And that's the best answer. Okay, on number 6, notice that it's cube roots this time, so our brain's got to switch back to the perfect cube list. Because the index numbers are the same, we can continue to multiply. We're going to multiply the numbers in front that we see first. 5 times 3 is 15. We're then going to multiply the numbers underneath, the radicands. 2 times 3 is 6. X to the first times x to the fifth is x to the sixth. Alright, you're going to look at the perfect cube list like I said before. Cubes are 1, 2 to the third is 8, 3 to the third is 27, then we got 64, we got 125, and the list keeps going. Please notice that the number underneath this cube root is 6, and obviously 1 is the only thing that divides into it. So 6 cannot be simplified. Next, you look at the x. It's raised to the 6th power. It's a cube root. 6 divided by 3 does work. So I'm going to go ahead and underline that. 15 just drops down. The cube root of x to the 6 is x to the 6 divided by 3, which is 2. And this piece I cannot simplify, so it's going to stay as the cube root of 6. And so this is my final answer for question 6. 15x to the second times the cube root of 6.